of course, right? So now, while talking about the supervised learning, if that baby want to recognize this is an apple and this is a banana, what I can do is, I'll do is based on the supervised learning algorithm, I'll take two baskets. Okay, so on one basket I'll write like apple. Okay, and I'll write like apple, and also I'll teach that baby like it is apple, 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 apple. Okay, so on that basket I'm going to load it with number of apples. Okay, only apples. And the another basket I'll write like a banana, and I'll tell that basket that is a banana, banana. Okay, inside that I'm going to load it up with bananas. Okay, so now totally we have two baskets. One basket which is already written as apple, which is loaded with full of apples, and another basket which is loaded with bananas. So that is the two basket. Okay, so apple basket and then banana basket is there. Okay, now I'm gonna give that two basket to a baby. Okay, so what the baby actually will do? So baby going to pick up each and every object, it will observe. So let us come back to the first question which I asked before. So what is the question? How can you able to identify that is apple and then banana? So I hope a lot of people have guessed the right answer, which are nothing but shape, color, and then taste. Right? These are the main keywords. So this is these are all the things which can also be called as features. Okay, so shape, color, and then taste. So while talking about the shape, of course, the banana shape is going to be completely different from the apple shape. And color, so while talking about the apple, here we have red apple, green apple, and then pale yellowish apple is there. And in bananas we have red, green, and then yellow, right? So these are the colors. And taste, let us skip that. So before that we have shape and then color, right? So if I want to train that baby, so as based on a supervised learning, I have two baskets. One is filled up with apple and another one is filled up with bananas. I'm going to give that two basket to a baby. What the baby will do? So that baby will it is going to take an apple from the apple basket. It already know this is apple because we have already told that this is apple, apple, apple. So it is going to take one apple and it is going to observe like this. Okay, so it is looking like different. Okay, it is apple. Okay, then it will keep like this, and then it will take another object or a banana from the bananas basket, and it will see that, and it will observe that, and it will keep like this. Okay, this is the banana. So likewise, it is going to take every object from apple basket and then banana basket, so it will gain some intelligence. So that kind of learning or that kind of teaching is known as supervised learning. I hope you all clear with the supervised learning, guys. That is nothing but a labeled data. Before itself, whenever we are going to start giving a data which is already been labeled, that is known as a supervised learning. If you guys want me to explain it in a digital format, simply I will create two folders, apple folder and then banana folder. Okay, so on the apple folder I'll put up with apple's images. So I'll put green apple images, red apple images, pale yellowish apple images, and half cutted apples. So likewise, I'm going to load up with apple's images completely, like nearly like thousands images of apple. Okay, whereas in the another, I'll create another folder. I'll put the name like banana. Okay, on the bananas folder I'm going to load up with bananas. Okay, and then I'm going to give that two folder to the algorithm to learn it. Okay, it is going to learn from that folder. Okay, it is going to learn, right, like what to say, it is going to analyze that data, and it is going to learn from the data, and it is going to have that intelligence. So that kind of learning is known as a supervised learning. I hope you are clear with the supervised learning, guys. Okay, so what is the thing? So first of all, here we have supervised learning means the data which is all labeled data. Okay, and also here we have so the labeled data which are nothing but we are going to create a two folders. One folder is named like apple and another folder is named like a banana, and inside that data are there. That data are nothing but which all are labeled data. Okay, that is known as a supervised learning. But while talking about unsupervised learning, it is unlabeled data. What does mean by unlabeled data? So let us take a same baby, guys. So for that baby, I'm going to give one basket, but on that basket, I'm not going to write that is apple, or I'm not going to write that is a banana, but I'm going to take only one basket, that basket which is going to be filled up with both apples and then banana. Okay, I'm going to give a single basket to the baby. On that basket, it is going to have both apple and then banana. I don't know whether that is apple or banana, but that baby will take one object from that basket. So for an example, it is going to take an apple first now. Okay, it is going to keep like this. Okay, it'll observe. Okay, it will keep like this, and if it is taking a banana, it will try to compare it with the previous object, and it will keep like, okay, it is not similar to it, it's totally different, right? So it will keep on the right side. Again, if it is taking an apple, it will try to compare, okay, is it going to be in the this category or this category? It doesn't know about this apple or this banana, but it can able to segregate the data or group the data. So apple or banana, so it won't about apple or banana, X or Y. Okay, it is going to group the data automatically. That is known as unsupervised learning. If you are talking about digital format, I'll create one folder. In the one folder, I'll put up with apple and then banana. So my algorithm can able to classify, it can able to group the data separately. Okay, it won't bother about that is apple or banana, but it can able to group that apples as a different thing or different categories and bananas as a different category. That kind of learning is known as unsupervised learning. Supervised learning means labeled data, and unsupervised learning means unlabeled data. So I hope you all clear with the supervised learning and unsupervised learning, guys. If you are clear with the supervised and unsupervised, you just post I'm super clear Sanjay in your comment box below. Okay, so supervised learning and then unsupervised learning. Okay, supervised learning is a labeled data where we need to label the data before we are giving it to the algorithm or a model. You can take it like any baby, you can take it like any way. And unsupervised learning means it is an unlabeled data where we need to provide the data which is completely unlabeled. So it is not about worry about real or fake news. It's an unlabeled data. Okay, and here we have third main types, which is reinforcement learning. So while talking about this reinforcement learning, so how many of you people guys watched Tom and Jerry cartoons? So if you have watched the Tom and Jerry cartoons, I hope you all know in each and every day what the Jerry will try to eat, guys. So if you know the answer, you can post your answers in the comment box. Each and every day morning, what the Jerry will try to eat. Okay, if you know the answer, you can post your answers in the comment box. Okay, so for an example, so because we are going to explore this reinforcement learning with the help of the Tom and Jerry cartoons. Okay, what is the thing is, each and every day, Jerry will come out from that hole, right? Small tiny hole. And first of all, what it will see, first of all, it will look where the cheese is, right? So it will look where the cheese is. I hope a lot of people have guessed the right answer. So it will try to find out where the cheese is, right? And next thing what it will try to do, it will try to observe where the Tom is, right? Because so its destination is going to be cheese, but there is a challenge, that is a Tom there, right? So that is the first thing. It need to observe the environment first. Okay, it should observe the environment first, like where there is a cheese and where is a Tom, right? For observing the environment, that's the first one in the reinforcement learning, observing the environment. After observing the environment, it is going to do some action. So what is the action? If the action is towards the cheese, it is going to get the reward, right? But if the action is wrong, so for an example, accidentally if it stamps the Tom's tail, then what it is going to be the scenario? Definitely it is going to get the beat, right? So for a beat from the Tom, right? So it is going to be smashed up by the Tom, right? So whenever the action is towards positive, if the action is good or if the action is great, then that is known as that on the time it will get the reward. Whereas if the action is negative side or if the action is wrong, then it is going to get the penalty or punishment. That is known as this reinforcement learning, guys. Okay, so I hope you clearly understand. So while talking about the reinforcement learning, first of all, observing the environment, and it is going to make an action. So while making an action, so if the action is positive, it is going to get the reward. If the action is negative, then it is going to get the punishment. That is known as a reinforcement learning. So I hope you are clear with the basic idea about supervised learning, unsupervised learning, and reinforcement learning. If you are super clear with the types, you just post I'm super clear with types, Sanjay, in your comment box. Okay, supervised learning, labeled data, unsupervised learning, unlabeled data, reinforcement learning, which is different, where it is going to be like reward and then punishment, reward or penalty based kind of learning. Okay, so let us explore some of the major algorithms which we can able to have, or which is already there based on different kind of types which are present here. Okay, so first of all, supervised learning. So what is the main types? So first of all, here we have classification and then regression. So what is this classification and then regression? It's simple, guys. So for an example, if you want to classify or if you want to classify this highlighter versus this mobile phone. So if that is the scenario, or if that is your problem, because you are going to be a problem solver, right? So if you are going to classify this, so if you want to classify a pen or pen with the mobile phone, or if you want to classify fake news and the real news, if you want to classify spam messages versus the non-spam messages, if you want to classify positive and the negative, if you want to classify brain tumor is there and the brain tumor is not there, and then cancer, positive cancer and negative cancer. Likewise, if we want to do any kind of classification, on the time we can go for this classification based algorithms. Okay, let us explore the classification algorithms later, but that is a classification. Okay, cat versus dog or sheep. So it is based on like this or that or that. So whenever your projects, your application needs to do a classification, so we can go for this classification based algorithm. Okay, whereas if you are talking about this regression, so what does mean by the regression? If there is any prediction, guys, so prediction in the sense, it's simple. For an example, you have a data, as you are a sales manager. Yeah, if you are a sales manager in automobile or in any product company. Okay, so if you have a certain data that so let us take different example. For an example, you are a stock or a stockbroker, something like that. Okay, so you can able to predict whether the price of the stock or the stock value of the next month of the certain company, which is going to increase or it is going to decrease. So like that, you are going to give the exact value, like approximate value even, right? And also the next example, for an example, if you are if you can able to predict the land price on 2025. Okay, if that is the scenario, so then you can go for this regression. So whenever there is a prediction kind of application, then you can go for regression based algorithm. Okay, so I hope you clearly understand the difference between the classification and then regression. Classification means it is going to be helpful for classify the objects or classify the other kind of conditions. Okay, positive or negative, fake or real, true or false, or cat or dog, or different kind of like line. So likewise, so that is a classification. Whereas if you are talking about the regression, it is about the prediction. So land price prediction, stock value prediction, or like what, a house price prediction. So whenever that on that scenario, we can go for the regression. And while talking about the classifications output, it is going to be a classes, whereas regression output is going to be a values. Okay, it may be a numerical values. Okay, that is known as a classification and regression. So while talking about this classification algorithm, here we have more different types of algorithms. So some of the algorithm here can be used as both for classification and then regression, but some of the algorithm can be only be used as a classification, and some of the algorithm can only be used as a regression. Okay, the algorithms such as k-nearest neighbor, support vector machine, decision tree, random forest, neighbors, neural networks, stochastic gradient descent, linear regression, logistic regression, polynomial regression. So likewise, we have different kind of algorithms where we can be able to use it for both classification and then regression, or sometimes like only for classification and only for regression. So I hope you clearly understand about so what is the problem statement. So how can you solve that? So let us have a certain question, guys, a certain example. Okay, so for an example, if I want to predict that what is the survival rate of Titanic disaster? Okay, if that is my problem. Okay, so I have my database that so already I have some of the data, like some of the lot of people, like out of 10,000 people, let us take for an example 10,000 people, I have some of the data. So on the 10,000 people, so you already have some of the data, like death rate and then recovery or escape rate. Okay, you have the data based on the age, based on the gender, based on the different kind of physical or health reports. So you have the data. Okay, if that is the problem statement, what is the thing which you need to find is you need to predict how many people might survive that Titanic disaster. So that is your challenge. Okay, so now you just tell me, guys, do we want to go for a classification based algorithms, or we need to go for a regression based algorithm? Okay, so I hope you clearly understand the question. I already have a database based on the gender, age, and then health, and whether the person have survived or not. So we have some data. Okay, so out of the data, so you have some values. So with the help of that, you are going to predict how many people might survive that. Okay, if that is the scenario, so you just tell me what is the thing. Okay, you just tell me whether you will go for regression or classification. Okay, so and then let us go for the unsupervised learning. While talking about this unsupervised learning, here we have clustering and then association. So these are all algorithms such as like a PCA, like principal component analysis, hierarchical clustering, singular value decomposition, independent component analysis, k-means clustering, and etc. So these are all the algorithm which is going to be helpful for grouping the data. For an example, you have some data points. So that data points which contains what to say, like what to say, like you have star coordinate and you have circle coordinates and you have square coordinates. So if you have these kind of huge data points, and with the help of this clustering based algorithm, you can able to group the data, you can able to categorize the data. So this is star and this is box and this is circle. So likewise you can able to group the data. So for that we can go for these kind of algorithms. Okay, that is unsupervised learning. And here we have reinforcement learning. So while talking about this reinforcement learning, here we have like various types of implementations. Like you can implement based on a model based or policy based or value based implementation. And while talking about the model, so here we have Q learning, Markov decision process, and there are a lot of algorithms out there. Okay, these are like we can go for reinforcement learning. And you can ask, what is the real purpose of supervised learning? So I hope these things you already know. So for an example, if you want to classify person or pen or notebook, so you can go for the supervised learning algorithms. For an example, if you are talking about any numerical values, so you can classify whether the news is fake news or real news. So Twitter fake news or real news. So let us take a best example. How many of you people know about the news that before President like Donald Trump, who posted certain tweet which has been automatically deleted by the Twitter algorithm? So that is based on a classification, because it is automatically identifying whether the message is any violence in the message, or any kind of fake news which is present in that message. Likewise, that algorithm which is automatically analyzing, which is automatically removing that tweet or removing that message. So for that we can for that only we will go for this supervised learning. Okay, that is the best example for the supervised learning. And unsupervised learning, it is like grouping a data. So grouping a data in the sense, you may have different data points, so more number of categories or more number of group of points. So that is going to be automatically categorized with the help of this unsupervised learning. And in the reinforcement learning, you can take like Google search, any search engines or any social medias, which is automatically analyzing you. Okay, which is it is based on observation. So it will observe you, how you are reacting, so how you are wherever you are visiting, and where you are showing interest, where you are spending more time on the certain post. So likewise, it is automatically analyzing you, and it will based on like progressive learning. Okay, it will learn and it will get the reward or punishment. Again, it will learn. So finally, it will have a throughout complete data where what is all your interest and what you are looking for and what you're going to become. So likewise, those kind of thing like progressive learning. So and also, if you want to create one game like artificial intelligence snake game. So I hope you guys have played snake game, right? So how many of you people played the snake games? So if you are talking about the games like snake games, so we used to play in our old days, right? So nowadays I think not any people are playing that, right? So while talking about the snake games, you can use this reinforcement algorithm to design automatic or autonomous snake playing system, okay, or designing a game. So with it can able to learn automatically. So while talking about the snake game, guys, what are the challenges in the snake game? So first condition, it should not collide with a wall. So that is the first thing. And second thing, it should eat the eggs or fruit, anything, okay, based on the snake game. So that is the second challenge. And third challenge is, it should not bite its own body or its own tail, right? So that is the third challenges. So these are all the challenges. And fourth challenges, it should find out the shortest path to reach the fruit or egg. That is the fourth challenges. Fifth challenge is, even though it is acquiring the shortest path, but sometimes it should go for the longest path so that it can able to cover the maximum cover area of the play, maximum area of the play place. Okay, so that is the challenge. These are all the challenges. Okay, so here we have progressive learning. So whenever snake is moving forward, so it should know whether it is going to bite its own tail or it is going to go for reward side. So based on that, it is going to be a progressive learning. So it is going to move, and it is going to learn. It is going to observe the environment, and it is going to take an action. If the action is negative, then it is going to get the punishment or the data point which is going to be reduced. Whereas if it is action is towards the positive side, then it is going to get the reward. So likewise, it is a reward penalty. So likewise, it is going to be a progressive learning. So where you can also create that kind of artificial intelligence based reinforcement learning based, like automatic snake game, like a snake game. So likewise, whatever will be the application where there is a progressive learning process, so for that we can use this reinforcement learning to train that kind of model. Okay, so I hope you clearly understand up to now. So if you clearly understood this, you just post I'm clear about machine learning basics, Sanjay, in your comment box. Okay, and remaining thing we have already seen that. So job opportunities and applications, and then how category. Okay, so now what we are going to do is, we are in this today's session we are going to start installing some of the libraries and thing which we really need. Okay, so first of all, you just I hope you guys all using a Google Colab, right? So please open your Colab notebook. Okay, now I'm going to show some of the I'm going to give you shortest procedure for installing a library. So what is the library we are going to use it for? Working on machine learning algorithms. Okay, so let us open the new notebook. Okay, so the most popular machine learning algorithm which we can use. So the machine learning algorithms, I think we already know, like we have different kind of algorithms like k-nearest neighbor, linear regression, logistic regression, polynomial regression, and etc. But here, if you want to know, or if you want to work about, like what to say, if you want to use that algorithm, if you want to use the logistic regression, so only way is you can use it with the help of a certain algorithm, right? So here, for even though you have lot different variety of algorithm, it is not required for you guys to use or import the certain algorithm separately. But here we have a certain algorithm which it can do that for us. So what is that algorithm is? That is scikit-learn library, guys. Okay, you just install it by using the command space called pip space install space scikit-learn. Okay, so this is the library which you can use it for machine learning algorithms. So whatever the algorithm which you need, so you can use it with the help of the scikit-learn library. So I hope you all following me. Please complete your installation by using pip install space scikit-learn library. Okay, so on the upcoming session, we are going to work on as like a complete project. We are going to learn some concept, and we are going to create as like a project. Okay, so like in a machine learning, so we have categorized our agenda like on classification, and in the regression, and in the reinforcement learning, and the neural networks. Okay, likewise we are going to explore as like a project. Okay, so I hope you are clear with this, guys. If you are super clear with this, you just post I'm super clear, Sanjay, in your live chat. Okay, so that's all up to the part, but before that I would like to give some introduction about this supervised learning concepts. Okay, so let us go for another mind map, which is supervised learning mind map. So while talking about this algorithms, guys, so as we have already discussed the 7 steps, right? So 7 steps in the sense, how can you deploy, how can you able to create machine learning algorithms? Okay, for an example, so there are some steps like preparing a database, and then proceed with the further process like cleaning a database, and training it with a different choosing a proper algorithm. And after that, we used to evaluate our model, right? Of course, so here we have this classification part. Classification purpose, which is going to be like classifying a discrete variable, zeros or 1, or 0 or 1, or 1 or 2 or 3, so like positive, negative, or neutral. So likewise, this is going to be output is going to be a classes, and examples like cat or dog classification, or a pen and then mobile, so it etc. And while talking about the steps, guys, so we already have some steps, right? So on the steps, I would like to give some introduction about evaluation. So what does mean by this evaluation? So while talking about this evaluation, guys, so here we need to evaluate our model. So what is our evaluation? So for an example, guys, as we have already given some problem statement, right? So it may be a stock value, or it may be a house value, house price prediction, it may be anything, but we need to know that what is the accuracy of the certain algorithm or certain model which is already been trained. For an example, if you are using linear or logistic regression algorithm, it has already done a classification. but still now we don't know how much accuracy is there. Okay, how it is classifying. So even though for 1 or 2 data it may classify it proper way, but for some of the data it may not classify properly. So that kind of model can be evaluated by using some of the methods like a holdout methods, cross validation method, ROC curve method, or classification report method. So likewise we may have lot of different methods to evaluate it. So I hope you all remember the steps, guys. Definitely we'll explore this evaluation later on. But before that, you just understand the workflow. So first of all, what is the first thing we need to do? We need to gather a data. So for gathering a data, we have used some of the medium like Excel, like websites like Kaggle also. So with the help of the Kaggle, or you can create your own data set, or you can collect the data set from the industry if they provide you. So gathering a data. And then what is the second step? We need to prepare a data. Preparing in the sense, for an example, if your data is in a different format, if it is in like an JSON format, to convert the data into a different format, or if you want to transform the certain data into a different form, or if you want to change the data type, that kind of transformation. And if you want to clean a data, so cleaning a data in the sense to removing the unwanted columns or unwanted rows, and to removing the empty values. So likewise we are going to prepare a data, because if you are going to provide, if you are a data analyst, you should give the proper to the machine learning engineer properly. But if you are a data scientist, definitely you also you are going to work from start to the end, right? So after the data which has been acquired from the databases, and data preparation which is going to be done, and then we need to work on a classifier or algorithm. Which algorithm we need? So based on our problem statement. So problem statement, if it is a house price prediction, I'll go for the regression based algorithms. If the output is spam messages, then not non-spam detection, so on that kind of messages, I'll go for the classification based algorithms, right? So for that we need to choose algorithm. So even though here we have one confusion, so which algorithm I can choose? So I have SVM, that is support vector machine classifier, that is SVC support vector classifier, and we have naive Bayes and decision tree, random forest. So here we have lot of algorithm, but still now we don't know which algorithm which is going to really perform well. So that what we can do is we can use that different algorithms, and we can able to get some matrices like what is the accuracy of, or we can able to evaluate it. Okay, so we can able to evaluate it by using this evaluation method. And once evaluation method is done for different algorithms, so we will come up to a certain decision that this algorithm which is really giving great accuracy when compared to the other algorithm for this current data set. So with the help of that, for an example, if SVM is giving 98.1% accuracy, and if naive Bayes is giving 96.2%, and if logistic regression is giving 91.2%, so out of that we have came into the decision that SVM is really performing well, so that we can choose that algorithm for proceeding with the training process, so like model.fit or model.fit transform. So with the help of that, we used to train the data. So training in the sense, like it is going to learn from the data. Okay, so that is the intelligence. So once you have got that model, so we can evaluate. So it is your option. So once the training is completed, what is your evaluation? So for an example, guys, so before processing, before giving the complete data to the model, so there is also an alternative way where you can able to split our data. So what does mean by data splitting, guys? So actually you just imagine, guys, you have one data. Okay, let us take a same example like fake news detection or apple versus banana classification. Okay, so you have 10,000 images of apple and 1,000 images of banana. So usually we won't use that complete 2,000 images for training, guys. Okay, there are three terms we need to know about it. First term, which is training. Okay, the data can be splitted for training or validation or for testing. Okay, there are three things, guys. Okay, so what does mean by the train data? So train data, which is simple, so which is going to be helpful for only for the training. Okay, not for any validating anything. Okay, so just for training. Okay, so our data can be splitted into three parts, or your data can be splitted into 2 parts. So it's up to you. Okay, based on your data which you have, and based on the algorithm which you're going to choose, and based on the validation methods, or based on the matrices which you need. Okay, so what is the training? So only for the training purpose. Okay, it is not going to use any other data, so it is only for the training. Validation, whenever the training process is going on, it can use the validation data set to cross verify it, or to validate our model for each and every epoch. So epoch is in the sense for each and every iteration it can able to give you the accuracy. So for the first iteration towards the 2000 data set, what is the accuracy? For an example, on the first iteration we have a 61.2% accuracy, and the second iteration we have 68.2%, and third iteration we have 71.3%. So likewise, for each and every iteration, it can able to give you the results. That is a valid like evaluation data set. So for that, we can use that validation data set for validating our model for each and every epoch or each and every iteration itself. And tested data set. So tested data set, which is going to be helpful for once the training is completed. So if you want to show the demo to your faculty or your mentor, okay, so on the time you should not use the same training data, because that is useless, right? So if you are training with the same data, and if you are testing with the same data, if you are validating with the same data, it is completely useless, right? So on the time, if you want to test or if you want to show for the new data, you can introduce the new data for the testing and you can show the output. So for an example, if I'm giving an apple and then banana, I already have 1000 images. Totally I have 2000 images. 1000 images of apple, 1000 images of banana. So actually I segregated the data, like 80% of the data for training. Of course guys, it is the rule, like where majority data should be for the training and remaining percentage need to be split up for validation and then testing. Okay, for an example, I have 100% of the data, like 1000 for apple and 1000 for banana. Now what I can do is I can categorize or I can group that or I can split the data, like 80% of the data for training and 10% for evaluation and 10% or 10% for validation and 10% for testing. Okay, so from that what we can do is, so I'll train it with the 80% of the data and I'll pass the validation data for validating for each and every iteration. It will give some accuracy and finally it will give the model accuracy and those things. And once it is done, so while showing the output, I'll use the test data set. Okay, I'll use the test data set, I'll load it up with the new images and I'll try to observe what is the result. So is the result is good or not? So likewise, we can use the test data set, guys. Okay, so that is the main purpose of splitting our data set. This especially for classification based algorithm. Okay, so I hope you all clearly understood up to the evaluation. So training, so once the training is completed, we can evaluate it. So what is our model's accuracy? So based on that, so for an example, we also have parameter tuning, so which is going to be helpful for increasing your accuracy further by tuning some of the parameters, so like hyperparameters, in the sense it may be epoch numbers, it may be a number of data set, or it may be a clean data set. So it may be your network design, so it may be anything. So there are a lot of parameters are there. So you can tune some of the parameters to get or to bring your accuracy more accurate further. Okay, so if you are getting 98.1% accuracy, if you are tuning some of the parameter in the algorithms or in a data set or in a different kind of like what network means or network design, so if you are tuning that, you may get 99.5% accuracy. Likewise, we can tune your hyperparameters to get a better accuracy. Once you got the better accuracy, now that model, you will save that model in your local directory, which means now that model is having that intelligence for classifying a certain object. Now you can download that model and you can use it in a different deployment state. For an example, so that is completely based on the framework, or that is completely based on the algorithms. So that model can be used it for prediction. So for an example, if I'm doing power monitoring system using Raspberry Pi, so I've already collected the data set from the Raspberry Pi or from the certain systems, and I've already trained it in my normal laptop. Now I'll train it and I'll evaluate it and I'll get the better accuracy and I'll generate one model once after it is crossed over the parameter tune. So I got one model which is in the percentage of accuracy like 99.8% accuracy. If that is my model, I can download that model and I can load that model into the Raspberry Pi. So Raspberry Pi kind of hardware where we can able to deploy the machine learning algorithm for prediction. So it will take the current data from the real home appliances and it will use the model's intelligence to predict whether the current voltage or current acquisition, which is normal, or is it high, or is it fault. So likewise, that kind of real-time monitoring, real-time prediction, or real-time classification system can be deployed with the help of that model, guys. Okay, so I hope you clearly understand up to now the procedure and then workflow. And in the upcoming session, we are going to work on the projects, guys. And I hope you all super ready for the session, because upcoming projects which can able to give it for your it will be like it is going to be very helpful for your profile also. So, and also it will be very helpful for understanding about the certain algorithms as well. Okay, so that's all up to the session, guys. So we are about 30-day success mindset exercise today. Yesterday's exercise, which is about write down the list of asset which you can create. So asset in the sense building a home and giving it for rent, or buying any vehicle and giving it as for rent. So likewise, whenever certain object or certain things which is giving you the income, like monthly income, which is giving you the money back again, that is known as a real asset. So that's why I really want you guys to write down the list of asset which you can able to build, like gold and those things. And today's success mindset is which is going to start about a practical task. Okay, from today, so remaining 5 days, we are going to do some practical things. Okay, so I hope you will do this, and I hope you all excited for this. So the first today's practical task, which is about declutter your physical and then digital workspace. Okay, so on the tomorrow's session, I'm going to show my desktop. So since it has already been decluttered, so declutter in the sense you are going to remove unwanted icons, unwanted files, which is all present in your desktops. Okay, because we have already written that, right? So decluttering our physical and the digital workspaces, right? So physical workspaces means your working table. So keep your working table like please use the concept like minimalism. You keep what you really want. Okay, other than that, you just keep it in any closed wardrobe or something like that.